brightest, in a dark night, you can make out millions of stars. Total solar eclipses are rare. Days get longer in the summer and shorter in the winter. High noon, the sun's directly overhead. Sun rises in the east and sets in the west. The moon comes out at night. What all these have in common is that they're all false. Every one of these is just false. But we've heard them and we retell them. And we retell them because we assume they're true, because either you want them to be true or they feel like they should be true, but they're not. They're not. The first one, what goes up must come down. That's true if you're just human, right? If you're just flesh, whatever you throw up, it comes back. That's kind of life experience. However, we've got like golf balls on the moon that are never coming back to Earth. Stuff that went to the moon reached escape velocity from Earth. There is a speed with which you can throw things, so they'll never come back to Earth, ever. Ever. We have 5 spacecraft that have achieved that speed in the history of the space program. Pioneer 10 and 11, Voyager 1 and 2, and the New Horizons mission. So good. So you hit escape velocity, it never comes back, ever. It'll go to the edge of the universe and never look back to Earth. So it's just false. The sun is not a yellow star. The sun is white, right? In broad daylight, in the middle of the day, you're not looking up at the sun because you'd be blinded by that. So when do you look at the sun? When it's low on the horizon, trying to eke its way through all the crud that's in our atmosphere, and all the blue and the yellow, then the green filters out, goes into the sky, and what looks like a yellow star on the horizon is not the true color of the sun. The true color of the sun is much better represented by when it's higher up in the sky. So the sun is just simply not yellow. By the way, if the sun were yellow, what color would snow be? Yellow. And there's only one place you find yellow snow. That's near fire hydrants, okay? So, weightless astronauts left Earth's gravity. That's baloney right there. They're weightless, but what do you mean? They're not having left Earth's gravity? No. There they are orbiting around the Earth. If they left Earth's gravity, what's holding the moon in orbit, all right? Just think this through. This doesn't take a grant from the NSF to understand, okay? I did this test. 9 out of 10 people, when asked, will tell you the North Star is the brightest star in the night sky. That's just not so. The North Star is not even in the top 10. It's not even in the top 20. It's not even in the top 30. It's not even in the top 40. The North Star is the 49th brightest star of the night sky, which means you've never been visually struck by it. You've never come out and said, oh my gosh, look at the North Star. You're not looking at the North Star. You're looking at like a planet or something. Like Venus is out there right now. Those who don't know that Venus is a planet are wishing upon it. Because you wish on the first star I see tonight? That's why your wishes never come true, because you're wishing on planets. On a dark night, you can make out thousands of stars, not millions. Try counting them. You won't get past a couple thousand, I promise you. I've done that, okay? Based on the list of who's co-sponsoring this event, there's like, it has a strong geek index there, right? The Sci-Fi Club and all this. The Aeronautics and Astrophysics Club or whatever. So I bet they've counted, because like that's what they're doing, you know, you do that at night. You're out at the bar, we're counting stars at night. All right. Solar eclipses are rare? That's just false. Every newspaper article that reports on a total solar eclipse says, rare eclipse today. Total solar eclipses happen every 2.5 years or so. They're more common than presidential elections, but they never say, rare presidential election coming up. Rare Olympics coming up. Days get longer in the summer and short. This is just false. Who here believed this until I put this up? Who here believed that? Raise your hand. Okay, and the rest of you are just lying, all right? But 9 hands went up. You all are honest people here, okay? The rest of y'all, I didn't see any hands over on the left side there. So, days get shorter in the summer and longer in the winter. Now, this is not magic thinking. Consider, what is the longest day of the year? Daylight, of course, is what is the longest day? June 21st. And what else is that day? The first day of summer. So if the first day of summer is the longest day of the year, then every other day in summer has to be shorter, doesn't it? Another fact that didn't require a grant to figure out. What's the shortest day of the year? December 21st. What else is December 21st? First day of winter. Every day in the winter gets longer. Sun rises in the east and sets. Actually, this is true on 2 days of the year. Every other day it rises and sets someplace else on the horizon. In the 2 days that happens is on the equinoxes. The moon comes out at night. Of course, it also comes out in the daytime. You're just not paying attention. So the problem is, when you hear information, you need to sort of think about, carry with you some skepticism of it. So scientists, we're aware of the way things work. We're fluent in math. That's the language of the universe. And it empowers ideas. Just empowers. A quick example. I did a poll. I went up to people in the car who were not wearing seatbelts, because you catch them at the red light. Do this in the spring where it's not cold enough to close the window to have heat and not hot enough to close the window and have cooling. So in the spring and in the fall, people driving with their windows open, I go up and I say, most of the time they just close the window real quick, but when they don't, I say, why aren't you wearing a seatbelt? I ask the driver, and the driver says things like, well, it crinkles my clothes, it constrains me, and I'm thinking, were you going to do like jumping jacks on the front? What do you mean you're constrained? You're sitting there. All right? So they say this, and they're given all these reasons. And then I ask, have you ever had a class in physics? The answer is no. Had they taken a class in physics, they would have learned Newton's laws of motion. And one of them is things in motion tend to stay in motion unless acted on by an outside force. So if you're in the car's going 20 miles an hour and the car hits a brick wall, the car stops. But you don't stop. You keep going 20 miles an hour into the windshield and you bust your face. So now people say, now, who here, if you don't wear a seatbelt, who here, let me ask it a different way. What speed is low enough for you to think to yourself, I don't need a seatbelt at this speed? The non-seatbelt wearers in this audience, answer that question for me. Give me a speed that you're pretty sure all is fine. Give me a speed. 30 miles an hour. There you go. One more. 30 miles an hour. Okay? 30 miles an hour. Okay. Because that's not that fast, 30 miles an hour. So let's go back to the physics class and let's find out something. All right. Olympic 100-meter sprinters, the fastest people in the world, can run 23 miles an hour. Let's round it, say 25 miles an hour. Okay? So what I want you to do, you're not going to be able to run that fast, otherwise you'd be in the Olympics. So what's the fastest you can run? Maybe 16 miles an hour. Okay? So here's what you do. Find a brick wall somewhere, put your arms behind your back, and just run face first into the brick wall. Just do that experiment. Run as fast as you can, face first into the brick wall. And then report back to me on that. And you will understand the meaning of seatbelts. Survival.
Really exciting news. Gravitational waves have finally been detected. Here's a brief explanation. Back in 1915, Albert Einstein gave the world his new theory of gravity, the general theory of relativity, which is based on the beautiful idea that gravity is nothing but warps and curves in the fabric of space-time. Now, barely a year later, Einstein pushed this idea one vital step further. You see, he realized that if space is flexible enough to warp, then it should also be able to ripple, to vibrate, to undulate. And that would mean that if something were to jostle the fabric of space-time, it should send out ripples in the fabric of space, and it's those ripples that we now call gravitational waves. Now, of course, the source of gravitational waves would not be my hand jostling space. Instead, it would be some highly energetic astrophysical process like rapidly orbiting neutron stars or black holes that would send out a steady rumble of gravitational waves. Or at least, this is what the theory says should happen. Now, how do you test this idea? Well, the math shows that as a gravitational wave rolls by, it will squeeze and stretch anything in its path. You see it happening here for the Earth, but of course, this is highly exaggerated so you can see the effect. When you do the calculation, you find that the amount of squeezing and stretching would be tiny, a mere fraction of an atomic diameter, and that makes it pretty difficult to detect. But that is what the LIGO team has now achieved. And they did it with two detectors, one in Louisiana, the other in Washington State. And in these detectors, what they do is they fire laser beams along two 4-kilometer-long evacuated tunnels. And when the light recombines, it creates an iconic pattern. It's known as an interference pattern. But the only thing that you need to grasp is that were a gravitational wave to roll by, it would squeeze and stretch the arms of the detector, and that would have a measurable impact on that interference pattern, causing it to shift. And it's just that kind of shift in the interference pattern that the LIGO team has now observed. The first direct detection of gravitational waves. And this is big. This will go down in the history of science as a pivotal moment. And not just because it's another spectacular confirmation of Einstein's ideas, which it is, but rather because for millennia we have explored the universe using waves of light. This discovery